So today, adding and subtracting radicals. So when you're adding and subtracting radicals, that means we're going to take something like the cubed root of 6 plus 4 times the cubed root of 6. Now there's a couple things that have to happen in order for you to add or subtract radicals. This only applies to adding and subtracting radicals, not to multiplying radicals. Anytime you add or subtract radicals, you got to look for two things. First thing you have to look for is you have to look for the index of your radical. That has to be the same. So in this case, we've got the cubed root and the cubed root. That has to be the same. The other thing that you look for is what's underneath the radical. And those have to be the same as well. If both the index and the radicand for that index are the same, then you can add those two together. If they're not the same, you can't. And you're going to treat this the same thing as this was x plus 4x. You treat it the same exact way as you would this. 1x plus 4x is 5x. So our x value in this case is a cubed root of 6. Our solution then is 5 times the cubed root of 6. But again, you can only do this. This only works if the index and the radical for that index are the same. You can have multi things going on, but if that radical and that index aren't the same, you can't combine them. And again, to combine them, just kind of how you would 4x plus x. It's just 5x's. And then just replace your radical with what was there. So the next one, we've got negative 3 times the fourth root of 6 minus 2 times the fourth root of 6. Again, I'm looking at the indexes. The indexes are 4 and 4. Underneath the radical is 6 and 6. They're exactly the same. That means I can just subtract the numbers. Negative 3 minus 2 is negative 5 times the fourth root of 6. And that's your solution. And you move on. It really becomes a lot like combining like terms. The next one is a great example of that. If I've got 3 times the fourth root of 3 plus 4 times the fifth root of 2 plus 3 times the fourth root of 4 plus 3 times the fifth root of 2. If I look at this, I only have 2 of them that are like terms. Indexes of 5 radicand of 2. So I can combine those. Both of these have indexes of 4, but what's underneath the radical is different. So because what's under here is different than what's here, I can't combine them. So since we can't combine those, we just write them down. So it's 3 times the fourth root of 3. We said we could combine these two. 4 plus 3 is 7. So plus 7 times the fifth root of 2 plus 3 times the fourth root of 4. That then becomes your solution. You can't combine those. You can't put them together. There's nothing you can do with it. It's just like x, y, z. You can't combine x, y, z. You can't combine fourth root 3, the fourth root of 3, the fifth root of 2, and the fourth root of 4. Can't combine them. You leave them alone. That part easy enough to understand? Okay, so then what happens if you have something like negative 2 times the square root of 20 minus 5? Now, as you look at this, you look at the index and you look at the radicand, number underneath the radical symbol. It doesn't look like you can put them together. The index is the same, but what's underneath is different. However, you do need to simplify them. So we revert back to what we did on Tuesday of last week, where we do our factor tree for 20. 20 breaks down to 4 times 5. 4 is 2 times 2. Because our index is 2, we're looking for partners of 2. There's partner. So we've already got a negative 2. Negative 2 times 2 is negative 4. So negative 2 radical 20 becomes negative 4. We still have a 5 there. It becomes negative 4 radical 5. These two things, here and here, they're equivalent to each other. Now, the index and the radical is the same. Radicand is the same. Negative 4 minus, there's understood to be a 1 there. So this is negative 5 radical 5. And that's your simplified form of negative 2 radical 20 minus radical 5. So then let's just jump back to the last one for a second. Couldn't I do that to the 4, make it 2 and 2?
Yeah.
But is it going to do any good? No. So it doesn't do any good on that one. That's why I didn't do it, because I knew it didn't do any good. But you always have to try if you don't know for certain if it works or not. Okay. So let's look at another one. Cubed root of 108 minus 3 times the cubed root of 32. Okay, so we'll work this one together. You can do the last one by yourselves. So we're going to break down 108. What times what? Anyone? 2 times?
Oh, it's 9 times 12.
9 times 12? Even better. 9 times 12?
I think so, yeah.
I think you're right. 9 is 3 times 3. 12 is 3 times 4. 4 is 2 times 2. So what is that simplified? What are we looking for? 2s or 3s? 3s. So we've got 3 3s, so that gets to come out. What do we do with those 2 2s? Does it become 2 or 4? 4. Got to multiply them back together. So the cubed root of 108 is the same thing as 3 times the cubed root of 4. Now we got to do the same thing for 32. 32 is 4 times 8. Yep. 4 is 2 times 2. 8 is 2 times 4. That's 2 times 2. There's a minus symbol, so I'm going to put a minus. There's a grouping of 3. So we got 3 2s. So 2 times 3 is 6 times the cubed root of 4. Now we have it how we want it. 3 minus 6 is negative 3 times the cubed root of 4. How did dance go?
Good.
Make 9 channels.
What?
Big 9 champs.
Whoop, whoop. Overall, too? Nice. So, kick 1. How'd Jazz do?
They got 3rd.
I got 3rd. Good for you guys. Congratulations. Nice. Nobody ever posts anything, so I can't ever see how you guys do. Questions with that one? We okay? All right, give that one a shot. -3 times the cubed root of 16 minus 4 times the cubed root of 32. Did you kick their butt? Wasn't even close. Or don't you see their scores?
Air goal?
Yeah,
It was really close.
was it?
Yeah. But we beat them in kick. They beat us in chess.
It doesn't matter. You beat them.
Yeah.
Could be by a quarter of a point. It doesn't matter. You still beat them. Section's then 2 weeks away? Yeah?
We don't have anything this week, and then next week we have a show.
You have your show this weekend?
Next weekend.
Next weekend?
How'd you get 12?
Oh, it's supposed to be, force.
I can't multiply. That better?
Mm-hmm. And it's supposed to circle like 2, 4.
That look right?
Second one?
Yeah.
That's right to me.
Yeah, that's right. Because we got 2 times, because we're looking for 3, right? So we got 3, 2, so 2 times, and then we got to multiply those 2's back together. Can you combine them? No, can't combine them. So you're done. Remember, when you've got these lonely ones sitting here, you got to multiply them together to get what's underneath again. Okay. So that is day 3 of 5 days of section 5, adding and subtracting radicals. Remember, when you're doing these, make sure that the index and what's underneath the radical is exactly the same. Okay. You're going to get a worksheet